We'll continue with the Math 4 review. We're on problem 3e, and it says perform the indicated operations and simplify. Once again, I apologize for the fact that they're a little bit blurry, but I will rewrite them so that you can see what they are. 3e is r to the 6th divided by 35t to the 9th. That fraction divided by the fraction r to the 4th divided by 14t cubed. Remember, when we're dividing fractions, the rule is that we want to flip the second one and make it a multiplication problem. So that's what I'm going to do here. Let me turn on my pen. Okay, so that means that will be r to the 6th divided by 35t to the 9th times 14t cubed divided by r to the 4th. I flipped the second one. And now I can start canceling factors that are alike, or start dividing factors that are alike on the top and bottom from either side, because remember, I could multiply first and then reduce, or I can divide out common factors and then multiply. So I can divide out an r to the 6th on this side of the fraction and an r to the 4th on that side, and it doesn't make any difference. Excuse me. So the first thing I'm going to do is see that I have a 7 in both 35 and 14, so I'm going to divide that out. 14 divided by 7 is 2, and 35 divided by 7 is 5. And now I have an r to the 6th over r to the 4th, so I'm going to use the quotient rule that says subtract 6 minus 4, that gives you 2. And that makes r squared, that 6 becomes a 2 because I subtracted 4 from it. Now I have t cubed over t to the 9th. You can say 3 minus 9 is negative 6. Remember, a negative exponent goes to the denominator to become positive. I like to say take the larger exponent and subtract the smaller one. 9 minus 3 is 6, and place it where the larger one was. So that t cubed goes away, and that becomes t to the 6th, because 9 minus 3 is 6, or 3 minus 9 is negative 6, becomes positive on the bottom. So I believe now we have divided out everything that we could. In my numerator, I'm left with 2r squared, and in my denominator, I'm left with 5t to the 6th. And as you can see, there are no factors alike in the numerator and denominator that I can still divide. So that is the final answer for that problem. Simplify. Okay, you can see we have a slightly longer, more complicated problem here because I have 3 fractions. I have the first fraction divided by the product of the second 2 fractions. Remember, if I were to multiply those two right here, first I would have one fraction that I would flip. So I'm going to go ahead and flip it as the 2 separate fractions. So that means I still have x over 2x squared minus 8x plus 32 times, I'm flipping this one now, that gives me x plus 2 over 5x plus 20. And I'm flipping this one, which gives me x cubed plus 64, again over x squared minus 4. Now everything's multiplication, so the next thing I have to do is factor each polynomial that is factorable. Of course, the x is not, so that just stays x. Here I have a GCF of 2, so I'm going to factor that out, and that leaves me x squared minus 4x plus 16. And now I need to check if that's still factorable. So I'm looking to see if there's anything that will multiply to positive 16 and add to negative 4. They, of course, if they're multiplying to a positive and adding to a negative, would both have to be negative. And there's no combination of factors of 16 that are both negative that will add to negative 4, which means that is not factorable, or that's a prime polynomial. X plus 2 doesn't need factoring. 5x plus 20 has a GCF of 5, so that leaves me x plus 4. And this one, remember, is a sum of cubes. To factor a sum of cubes, I take the cubic root of the first the same sign, the cubic root of the last. Cubic root of 64 is 4, because 4 times 4 times 4 is 64. Remember, when you're factoring a sum of cubes or a difference of cubes, once you have your first binomial, don't look at that anymore, look at this one. That's square the first, use the opposite sign, multiply the first times last, which gives me 4x. Then always use a positive sign and square the last. And there's your trinomial, which is not factorable. Now here I have a difference of squares, so that's going to factor to the sum and difference of their roots, which means it's x plus 2 times x minus 2. Okay, everything's factored now, so I can look for factors that are alike in the numerator and denominator so that I can divide them out. And right away I can see that this trinomial and this trinomial are the same, so they will divide to 1 and divides them out. I have an x plus 2 here that will divide with this x plus 2. I have an x plus 4 here that will divide with this x plus 4. And now the only thing I have in the numerator is an x. And in my denominator I have 2 times the quantity x minus 2. And that's my final answer. Okay, now we're beginning on 4a, and the instructions say perform the operation and simplify. If you look at this problem, the operation is subtraction, and I already have a common denominator, so I don't need to change my numerators or denominators in any way because I already have a common denominator. So all I'm going to do is, whoops, need my pen back, don't I? So all I need to do here is combine, or in this case subtract, my numerators over my common denominator, which means I have 3 minus 9 over my common 20c squared. That gives me negative 6 over 20c squared. Do I appear to be finished with that problem? Think about it for a second, and of course the answer is no, because negative 6 and positive 20 have a common factor. That factor is 2. 2 goes into both of those. 2 divides into 6 3 times. 2 divides into 20 10 times. So my final answer will be negative 3 divided by 10c squared. I know that I'm finished now because there are no common factors in the numerator and denominator. I have a negative, it's in the numerator, which is where it's supposed to be, not in the denominator. So that's my final answer.